Hello everybody, welcome to Alex Does LeetCode, where we work on programming problems together on stream. Alright, so today's problem is going to be rotate image. Let me just turn off my echo. I've got another version of me coming up on the other screen. It's kind of a weird dystopian thing. So today's problem is called rotate image. It's a medium problem, number 48 on LeetCode's list. Let's start as usual by looking at what the problem is asking for. We are given a n by n two-dimensional matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the two-dimensional matrix directly. Do not allocate another two-dimensional 2D matrix to do the rotation. Okay, so let's look at some examples and what it's actually doing. So you can see, essentially, what we're trying to do is to rotate the elements of the image, right, of the matrix. This is actually a very common thing that you need to do when you're doing image manipulation. You want to rotate a photograph, a bitmap 90 degrees. This is pretty much the same thing as what you do. And because of the size of the bitmap, sometimes you just want to do it in place instead of taking a whole bunch of memory to do it. So what that means is you look at one is rotated this way clockwise. Everything is sort of rotated 90 degrees. So it gets to here. If you look at like number 3 was here, it's rotated 90 degrees. And now it's here, the new position. You take a look at number, I'm just going by examples, right? Let's say number 8, right? Number 8 is rotated 90 degrees also, and it goes to here. So you're basically rotating each element by 90 degrees. So that's also how I want to think about the solution to the problem. I want to think of it as copying elements. Oops. Let me switch to dark mode here. Okay, that makes it a little bit easier to see, I think. What we want to do is think about this as copying elements from one square to a different square. So we want to do a few things. First, figure out which elements to copy. Well, the intuitive answer is, well, copy everybody, right? Just copy everybody. But hey, look at this picture here. Number 5 actually stays put. So number 5 stays put. So you don't actually want to copy everybody, I think. And then, for each element, figure out where to copy it to. Let me get rid of this. Yeah, let me put this over here. Yeah, where did I put this? Let's put it here, right? We want to figure out where to copy it to. So the second problem is a bit easier. So given an item, right? Let's say its coordinates are x and y. It's new x and y. So we have to do some math here. Let me see. So let's do the math together. Let's say this is 0, 0. That's number 1. We're going to copy this to this is, let's say we have column indexing. Column indexing will be 0. Oh, whoops. Yeah, 0. This is still column 0. 3 is still column 0. And then this would be n minus 1. And then what about, let's try a few and see where we get. So 0, 1, and this is this 2 over here. It goes to here, So this will go to 1, comma, n minus 1. Okay, so we got a bit of a pattern here. So let's see. Let's try one more. Let's try number 7. Number 7 is located at n minus 1. That is, we're doing column first, right? Or rather, like, row first. And 0. And then it goes all the way to here, which is 0, 0. Okay, so we're starting to see a pattern emerge. So we want to transform each element from x, or from xy to new x and new y. Basically, new x equals to y, is to oy. And new new y equals to n minus 1 minus x. Yeah. So you can see the pattern here. Right? This 0, this new y is equals to oy. New x equals to oy. New y equals to n minus 1 minus x. And if you think about the mathematics behind it, it's not, I want to say it's not unintuitive. New x equals to y because the more this way it gets, the more this way it gets, right? So the more further down, 1, 4, 7, the more this way it gets. Yeah. Okay. I'm not gonna try and explain that. Okay. So we have a plan here. So we have a plan for getting new x and new y. Okay. So the next thing we need to do is to figure out what elements to move. So the naive way to do this would be to move all elements. Right? That sort of makes sense. Let's see. Let's do a quick n equals to length of matrix. So we're going to assume that the matrix is square. M by n, yeah. In range of n for y in range of n. Okay, and then we say, we might think naively we're going to do something like this. Matrix new x new y equals to matrix x y. So we want to do something like this, but not exactly this, because this doesn't actually work. And the reason is because we will move, if you think about what we're actually doing when we write a code like this, is that we will end up moving 1 to 3. We're going to take this 1, we'll move it here. And then this one will move to here. and then this one will move to here. But the one still stays, right? And the 9, you look at this 9 here, it actually disappears. So we are sort of copying in place and we're copying destructively. That's not good. We're copying in place and we're copying destructively. And so, for instance, our matrix will start off as 1, we'll copy it to 3, and this one becomes 1. 2 will copy to 6, and this one becomes 2. So far, so good. And now we get to this square right here, and the 3 is gone. Now it's going to take 1, and it's copied that 1 to the 9, and that's not what we want, right? That's not what we want. So essentially, what we want to do is we don't want to move the whole matrix. Instead, what we want to do is to move only one quadrant. Only one quadrant. We're gonna move we're gonna move this, and as we move this, we're gonna move each square we have. We're gonna move his other three friends. So, for instance, 1's friend is 3, 9, and 7. 2's friend is going to be 2, 6, 8, and 4. Right? We're gonna move his other 3 friends. So likewise, let me see if we can scroll down. Probably not. So in this example, for instance, when we move 5, we will move 5, 11, 16, and 15 at the same time. And we move 1, we'll move 1, 10, 12, and 13 at the same time. Yeah, so we move sort of these all 4 things. Right, when we get to the middle, we'll move like 4, 8, 6, and 3. And we do sort of like a musical chairs where they all swap positions. So when we move a thing, we don't just move it, we move all 4 things. Now, so this is a slightly tricky part. The other thing is the other trick is we don't have to do x in range n, y in range n. We just have to move one quadrant of the array. Okay, this is for when the array is an even number. When n is an odd number, let me see. I'm not sure what happens when n is an odd number. I'll think about it. When n is an odd number, I'm actually moving this. Okay, cool enough. I think I got it. Let's call this, I hate to use variables like this. Let's call this a and b, where a is the maximum of x. Actually this is a and b, where a is the maximum of y and b is the maximum of x. Okay, so let's see. What does the picture look like? Okay. So A is basically n divided by 2 rounded down, and B equals n divided by 2 round up. How do I round up again in Python? Round up to ints. Oh, damn. Seal. Okay. Math.seal. Okay. So in this case, A and B will both be, when n is 4, in this case, because n is 4, A and B will both A equals to B equals to 2. In the case that we have like an array of 5 by 5, and we want this thing here, then A would be 2 and B will be equals to 3. So round up and round down. So this should work. Okay, so we need to not just figure out, we need to do all 4, we need to do this 4 times. Well, we need to do this 3 times. Let me see. Well, we're gonna do it some number of times. Okay. Well, we just copy and paste. Let's see what happens when we copy and paste. New x equals y. So instead of copying this first, we have to yeah. We're to basically repeat this 4 times. So each time we're gonna calculate a new x, new y. We are going to so this will copy. This step will copy 5 to here, 5, and then val. This val equals 11. So we keep it for next place we want to copy to. Wait. Oh wait, I can't do this. This is a bit annoying. So this copies to here. This copies here, this copies here, this copies here. So this guy, when I copy this, I need to keep this value. Let's just write the whole thing out. New y, and then repeat this. Wonder if it's easier to do copy from. Yeah, it's easier to do copy from. So we're going to restructure our code so that when we have 5, we're going to copy from 15 and then put 5 into val. Yeah, this way, okay. So this way val and the current number will look different. So this will become 15. And then 5 will be val. This makes it a little bit easier. A little bit prettier. I won't say easier. So in this case, then I'm going to I have to recalculate new x and new y actually. Huh. Nope, still doesn't work. This is a little bit annoying. What am I getting wrong here? Let me think about it for a while. So the problem I have now is a really, really weird problem. I didn't actually think about it before. It should be a hard problem to solve. So what happens is I take 5, right? I copy it here. Now I know val equals to 11. Okay. Now when I copy 5, when I put this val into 16, I need to take the val, put it into 16, and take 16 out somewhere else. I think the easiest way to do this is to say new val equals to this, and then this equals val, val equals new val. Okay, so this will work. So new x. Let's see if let's go through the logic to see if it's right. So new x. So x equals to x and y. Let's start from 0, 0. New x equals to y. So new x is equals to 0. And new y equals to n minus 1 minus x, which will be here. Okay. And then the next step is I'm going to say new val equals to this. So new val equals to 5. And then matrix equals to val. Okay, I'm going to need the initialized val here. So let's say val equals to 5. Okay, I'm going to copy 5 to here. Okay, and then val equals new val. Oh, new val is equals to 11. Val equals new val. Okay, cool. Yeah, I think this is right. So I do this 4 times. And I think this should work. Let's run it and see what happens. It may not work though. Okay, test case accepted. Let's submit this and see what happens. Oh, well, it works. But it's slow. Why is it slow? I'm curious about this. It's probably because I bet it's slow because of this. I wonder if I can do this. Would this make it faster? Just to say, I don't need I. Oh, makes it quite a bit faster. I don't need I. Just let's throw it away. Yeah, so this makes it quite a bit faster, surprisingly. I think there's something to do with this val and new val that makes it even faster. I'm not sure. Let me see. So one thing I can do without, so the reason why it's a bit slower is because of all these copies. So one thing I can do is actually to move backwards. Instead of x equals new val, I'm going and y equals new val, because what I'm doing is I'm going to say step 1, 5. Oh, whoops. 5 goes to 11. Right? Instead of that, I should have. Yeah, that means I do have val and new val and do a little bit more copying. I wonder if it's faster if I just keep val equals to 5. And then what I do is I turn this into 15. Turn this into 16. Turn this into 11. And then turn this into 5. I wonder if that would be faster. And what that means is that I'm going to first calculate I have to calculate inverse. Instead of new val equals to this, I am going to copy clockwise. Excuse me. While I move anti-clockwise. So I have to calculate the inverse of this. So this is like a, let's just pick this. There's a bit of math here. Welcome. I see a new viewer to our channel. Things are a little bit quiet today. That's fine. So this 1 is at 0, 1, and this 13 is at n minus 1 minus 1, comma 0. So new x equals to n minus 1. So n minus 1 is the last thing on in the array. Minus y, and this is equals to x. So val, so basically what this does is it'll keep val. Val is, let's say 5, new x, new r. And I don't need this new val. I just say matrix x y equals to matrix new x new y. I don't need any of this. And then x equals to y, y equals to, let's see if this works. Oh no, it doesn't. Okay, so it doesn't work. I do this 3 times. So at first, x and y equals to 0, 0. New x equals to x, okay, is this one. And I say equals, okay, this is correct. Oh no, I have to move it this way. I think this is correct. So new x equals to So basically, what I'm doing here, I already completed the problem. I'm trying to see if I can make it even faster. And the idea is I have this like ugly swapping thing in my previous solution. I want to make it go away. And I think the idea here is I'm going to start with this. I'm going to stick it into a place called val. So only one copy. And then on my first move is to take 15. I'm going to copy it here. Yeah, I think this should work. Why shouldn't it work? That's funny. It should work. So new y equals to, so when this is 0, this is n minus 1, this is 0. Yeah, this is 15. And then I copy it here. And then now my x equals to y. Oh no, x should be new y instead. New x. A new y. Let's run this. Nope, it doesn't work. Huh. Why doesn't it work? Okay, let's try this in, let's do some visualization here. Let's try this in Replit. No, don't do this. Okay, let's try this in Replit and see what Replit tells us. S equals solution s dots rotate. So this gives us a chance to play around with Replit also. Rotate. M equals to blah. Rotate M. Okay. Let's run it. Let's run this debugger. Oh, I need to, one more thing. The last thing I need to do is to put val. So matrix, I think it's new x, new y. No, matrix x, y equals to val. Okay, let's run it and see what happens. A bit curious. Okay, so we are here. We run the next breakpoint, which is at 15. Oh, what happened? Oh, list not defined. Ah. Math is not defined. Oh, import math. So generally you don't want to do import math. Let's do it the right way. From math, import cu. So we only use one thing in math. So let's just use that one thing instead of importing the whole math library. Okay, just make sure, let's run it once to make sure that it completes. From math, import cu. Oh, so it returns, it completes. Print m. Just for fun. Okay, cool. So now we try it again with debugger. We have a breakpoint on 15. Let's stop at 15 and see what happens. So we have A is 2, B is 2. That's not actually correct. Wait, what is n? N is, oh, n is 4. Okay, cool. So this is correct. Okay, next step. X is 0, Y is 0. Okay, so we don't need to see this. We just focus on this. New X is 3, new Y is 3. Let's draw our picture here a little bit, so we can visualize a bit better. So this is correct so far. And then val is 5, that's correct. xy equals new x, okay, that should be correct. So now we move 15 here, which is what we want. Okay, new x and new y. Okay, new x and new y are 3 and 0. 3 and 0, so we're here. Let's see what happens here. Okay, now new x, new y is 3, 3, which is here. Yeah, this should be correct. What's wrong with this? Okay, so now this is going to be here 16. We have 16 here. Perfect, right? This looks right. Let's run it all the way to the end, to here. Okay, so here x and y should be 0, 0. Oh, x and y are not 0, 0. Oh, x and y are not 0, 0. Interesting. X and y are... But new x, new y should be 0. Y is 0, 3, and why is new x, new y 0, 3? New x, new y is 0, 3. So we copied this here, and this here. Oh, I see. 0, 3. So x and y should be... Yeah, no, this is right. X and y, this should be 5. Equals to val. Why is this wrong? Okay, let's take a look at what was actually wrong here. So what was wrong? So 15, 12... This shouldn't be 11. This should be 5. Let's see what's happening here. Oh, this is 5. Okay, now this is extra odd. Something is going on. Just let it run a few times. So it's 15, 13. Wait, my output is correct here. Let's just run it to the end and see what happens. Oh. Why is X and Y so weird? Why is X and Y 1 and 3? B should be 2. Oh no, this is fine. 1 and 3. 12, 2. Okay. Something is wrong here. Not figuring out what it is. X and Y are 0, 0. So I want to verify that it's 15, 11. What should be? Yeah, let's take out this breakpoint. So 15, 5. And then at the other side, it should be 16, 11. 16, 11, that's correct. So 13. So now we're rotating this one, right? So we have checked that it's 13. And then the second row, last element should be 1. Last element is 1, correct. Third row, first element should be 12. Third row, last row should be 10. That's also correct. Now X and Y is 0, 1. Two, 5. Fourteen, 4, 8, 1. Fourteen, 4, 8, 1. 12, 3, 6, 9. 12, 3, 6, 9. Okay, so this looks like 7, 16, 7, 10, 11. 16, 7, 7, 11. So this looks correct. So it's just the last one. What's wrong? Okay. I think it's because I'm messing around with X and Y. I think that's what's causing the... Okay. So now it's exactly correct. It's 12, 15, 12, 2, 5, 15... Well, the 12 will be copied. 2, 5, 14, 4, 8, 1. Ten, 3, 6, 9. 10, 3, 6, 9. Huh. Well, I'm not sure, but I'm not sure. I have to think about it for a while. But what I do know is the previous solution actually works fine. Let's see if I can get it back to a previous solution, so I don't mess up my my own code. Make sure this is the right solution. I think this is right. This is what we had before. Okay, it's a little bit slow. I'm gonna think about how to make this a little bit better. But in the meantime, I think we are good to go for today. We have solved the problem, which is what we were going for in the first place. So thank you again very much for tuning in. See you next time. This Saturday, we're going to be doing our LeetCode contest again. So remember, tune in early. I don't think I'll be starting streaming at the start of the contest. So I will only start streaming at 11:30 so that people can't copy my answers. Basically, yeah. So what that means is please come early. Please come early at the start of the contest, which I think is contest start time. Contest start is on Saturday, 23rd December at it's either 9:30 Eastern time, which is my time, or it will be, this is AM, or I think it will be 8 p.m. IST. So come by and watch, and I will start talking about answers at 11 a.m. here, which will be 9:30 p.m. IST. And we'll discuss answers together. Work on the contest on your own. I really hope that you guys do better than me. And I'll catch you next time. Ciao.